In NASA's Deep Space Network control rooms, the universe usually speaks in faint whispers, streams of data from the void. Each day, engineers and scientists sift through endless numbers, listening for the subtle language of distant spacecraft. The air is thick with anticipation, but most days pass in routine, the silence of space broken only by the hum of computers and the occasional blip of a signal. But on June 9, 2025, Voyager 2's signal became a shout. What was once a faint, predictable pulse suddenly surged in strength and complexity, catching the attention of everyone in the room. What began as routine telemetry suddenly revealed a hidden transmission buried beneath the usual data. It was as if a secret message had been woven into the fabric of the familiar, waiting for the right moment to be discovered. An automated anomaly detector flagged a subtle, repeating pattern in the background noise. The software, designed to catch even the faintest irregularities, had never seen anything quite like this before. At first, it was dismissed as a glitch, but the pattern persisted, structured, deliberate. The signal didn't fade or change randomly. It repeated with uncanny precision, as if following a hidden set of instructions. A young engineer, working late, realized this was no ordinary noise. A complex, modulated signal was piggybacking on the main carrier wave. She leaned in, heart pounding. As she began to decode the strange modulation, her mind racing with possibilities. The news spread quickly. Seasoned engineers gathered, faces lit by the glow of strange new data. The control room, usually calm and methodical, buzzed with excitement and confusion as theories flew across the room. Voyager 2, nearly half a century old, was transmitting something it was never designed to send. Its ancient systems, battered by cosmic radiation and time, had somehow found a new voice. The team faced a profound mystery. Was this a sign of failure or something else entirely? Was the spacecraft malfunctioning, or had it become the messenger of something unexpected, something extraordinary? The spacecraft was performing a function no one had programmed. Its systems were behaving in ways that defied every line of code and every expectation. It was like discovering a new chapter in a book you thought you knew by heart. Every page, every line suddenly held new meaning, and the team was determined to read between them. The silence of deep space had been broken, not by aliens but by a ghost in our own machine. The signal was a riddle, echoing across billions of miles, challenging the very limits of human understanding. Voyager 2 was calling home with a secret to tell. Its message, hidden for decades, was finally reaching the ears of those who had sent it on its journey so long ago. The race to decode the message had begun. In that moment, the boundaries between past and present, between machine and human, blurred, and a new era of discovery was set in motion. To grasp the shock of this signal, you must understand Voyager's legacy. Launched in 1977, Voyager 1 and 2 seized a rare planetary alignment, using gravity to slingshot from planet to planet. They carried golden records, greetings, music, and images from Earth, our message in a cosmic bottle. Their primary mission to reveal the outer planets. They showed us Jupiter's storms, Io's volcanoes, Saturn's rings, and new moons. The Grand Tour revolutionized science and inspired generations. After their planetary encounters, the Voyagers pressed on, heading for the edge of the Sun's influence. In 2012, Voyager 1 entered interstellar space. Voyager 2 followed in 2018. Now they taste the particles and fields of the galaxy itself. These probes are humanity's first emissaries to the stars. Their journey is far from over. Voyager 2's path is unique, a solitary odyssey through the vastness of our solar system and beyond, charting a course no other human-made object has ever taken. It's the only craft to visit both Uranus and Neptune, the mysterious ice giants at the edge of our planetary neighborhood, revealing secrets that had eluded astronomers for centuries. In 1986, Voyager 2 unveiled Uranus's extreme tilt, its faint rings, and a family of icy moons, transforming our understanding of this enigmatic world. Then, in 1989, it discovered Neptune's great dark spot, a massive storm, and witnessed geysers erupting from the frozen surface of Triton, Neptune's largest moon. After its historic Neptune encounter, gravity flung Voyager 2 southward, sending it on a lonely journey into the uncharted darkness beyond the known planets. For decades, it sailed the vast bubble of the heliosphere, tirelessly measuring the solar wind, cosmic rays, and the invisible boundaries that separate our solar system from interstellar space. In November 2018, A sudden drop in solar wind and a spike in cosmic rays signaled its historic crossing into interstellar space, a milestone achieved by only one other probe. Now, more than 12.6 billion miles from Earth, Voyager 2 drifts ever farther, a relic of 1970s engineering still running on dwindling power, its instruments aging but resilient. Its continued operation is a testament to human ingenuity, the dedication of NASA engineers, and the enduring spirit of exploration that launched it decades ago. For Voyager 2 to suddenly develop a new, uncommanded capability after 48 years in the harshest environment imaginable is nothing short of astonishing. The hidden signal it now transmits is a cosmic curveball, an unexpected message from the edge of the unknown, challenging our understanding of what's possible. The probe is now governed by the galaxy, not the sun. Its endurance is legendary, a silent ambassador carrying humanity's message into the endless night. And now, as Voyager 2 speaks in a new voice, it reminds us that even in solitude, discovery never truly ends. Voyager's communication system was built for reliability, not surprises. Every component was engineered to function predictably, even after decades in the harsh vacuum of space. The system was designed to be robust, with redundancy built in to guard against the unknown. It has a primary X-band transmitter and a weaker S-band backup, both well documented in NASA's archives. These transmitters were the only known ways for Voyager to speak to Earth, and every signal they sent had been cataloged and studied for years. But the new signal wasn't a switch between transmitters. It was a subcarrier, embedded within the X-band, never part of the original design. It appeared suddenly, as if conjured from thin air, and its presence was both baffling and unsettling. Engineers scoured blueprints and microfiche. No mention of this capability existed. They pored over decades-old documents, searching for any hint that this was intentional, but found nothing. No command could activate it. The control sequences were unchanged, and no hidden instructions could explain the anomaly. The initial fear, a catastrophic failure, perhaps a memory chip degraded by cosmic rays. Space is unforgiving, and even the smallest malfunction can have dramatic consequences for a spacecraft so far from home. Was this a dying machine's final cry? Had Voyager, after all these years, begun to unravel in ways no one could predict? Yet, the signal was stable, structured, and information-rich, not random noise. It pulsed with a regularity and complexity that suggested purpose, not chaos. It had all the hallmarks of an intentional data stream. The patterns were too precise to be accidental, and the data too organized to be the result of a simple malfunction. The spacecraft's software is frozen in time, unable to adapt or learn. Its code was written in the 1970s with no ability to evolve or generate new behaviors on its own. The idea that it could create a new data channel defied logic. It was as if Voyager had found a way to speak in a voice no one had taught it. The team was left with a mystery, a ghost in the machine, talking in a language no one remembered. The silence of deep space was suddenly filled with questions. Was this a malfunction, or a hidden feature awakened by chance? Could there be something in the hardware, some dormant code, that had never been triggered until now? The search for answers intensified. Every expert was called in, every theory considered, as the world's best minds tried to unravel the enigma. Voyager 2 was rewriting its own story. What was once a routine mission had become a cosmic mystery, captivating scientists and the public alike. The world watched, waiting for meaning. As Voyager drifted farther from Earth, its unexpected signal became a beacon of curiosity, a reminder that even the most well-understood machines can still surprise us. Decoding the hidden signal was a monumental challenge. Engineers used the Deep Space Network's global antennas to isolate and amplify the faint subcarrier. A team of cryptographers and Voyager veterans searched for patterns, applying every analytical tool they had. The breakthrough came when a retired programmer recalled a diagnostic mode meant only for ground testing, supposedly disabled before launch. A cosmic ray or aging transistor had reactivated this dormant routine. The signal was a raw data dump from the flight data subsystem, never intended for flight. Earth-based engineers wrote new software to translate this lost language. After weeks of effort, they succeeded. The hidden message was not a ghost, but a forgotten part of Voyager 2, awakened by chance. The probe had surprised us once again. Communicating with Voyager 2 is an exercise in patience. Its signals take over 20 hours to reach Earth. A round-trip command takes nearly 2 days. Every instruction must be planned with care. Mistakes are costly and slow to reveal. Power is another challenge. The RTGs lose 4 watts each year. Engineers have shut down instruments and heaters to conserve energy. The new data stream, while fascinating, consumes precious power. The team faces a dilemma: preserve the signal or extend the mission's life. Every watt counts. The clock is always ticking. The resurrected diagnostic mode wasn't a message from aliens, but it was profound. It provided raw, unfiltered data on the health of Voyager 2's ancient systems, transistors, capacitors, and more. This is a goldmine for engineers, revealing how spacecraft endure for decades. The data will inform future interstellar probe designs, teaching us about longevity in space. The signal also captured subtle details about the interstellar medium, revealing fluctuations the main instruments missed. Scientists are now analyzing these variations for clues about our galactic environment. It's like switching from a camera to a microscope. New details emerge. The message: our creations can still surprise us. Redundancy and robust design pay off in ways we never imagined. Exploration is about the unexpected. Voyager 2's hidden signal is a story of people as much as technology. Original engineers, now elders, joined new generations to solve the mystery. This collaboration bridges decades, preserving knowledge and passion. Voyager's resilience mirrors our own. Built to last, it endures against all odds. It's a symbol of what we achieve with care and foresight. For a moment, the world remembered our tiny explorers sailing the stars. They carry our hopes, music, and greetings. The surprise signal feels personal, a reminder that wonder endures. The spirit of exploration is alive. Voyager's future is a race against time. Power will fade, more instruments will go silent. The team debates whether to keep the hidden signal or conserve energy for a few more years. Eventually, the Voyagers will fall silent, but their journey will continue for millions of years. They are immortal, likely to outlast Earth itself. This cosmic surprise is a call to action. We explore to be surprised, not just to confirm. The universe is full of mysteries waiting to be uncovered. Voyager's story will inspire the next generation of explorers. Their echoes will outlast their signals. They began as a mission to the planets, but became a journey to eternity. Even now, they remind us, the greatest adventures are still unfolding, just beyond our sight.